Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Structure I bicyclo 4.4.0 decane 4A 8A dione decalin 1,8 dione to 6-membered rings fused at the junction bearing the two carbonyl groups. The two carbonyls are at the bridgehead adjacent positions, forming a 1,2 diactone in a 6-6 fused system. Structure 2 bicyclo 4.3.0 nonane 3A 7A dione hydrindane dione 6-membered and 5-membered rings fused with the two carbonyls at the ring junction 1,2 diactone in a 6-5 fused system. Structure 3 bicyclo 2.2.1 heptane 2,3 dione norbornane 2,3 dione, a highly strained bridged bicyclic system with adjacent diactone. Moving on to the next step. For 1,2 diactones, alpha diactones, in cyclic systems, enolization is favored when the resulting enol can be stabilized and when the geometry of the ring allows favorable overlap. The ring size and fusion geometry play critical roles. Moving on to the next step. Effect of ring size and angle strain. In structure I, 6-6 fusion, the two 6-membered rings provide a relatively relaxed geometry. The alpha diactone at the ring junction can enolize. The enol benefits from conjugation with the adjacent carbonyl. The CH alpha to the diactone is accessible. In structure 2, 6-5 fusion, the 5-membered ring introduces more angle strain and the carbonyl-carbonyl system is slightly more strained geometrically. Enolization is somewhat more favorable because the 5-membered ring carbonyl is more reactive and the enol is stabilized. In structure 3, norbornane, the bridged bicyclic system with a 2,3 diactone is highly strained. The Brett's rule-like constraints mean the enol double bond would be at a bridgehead adjacent position but is not bridgehead itself, so it is accessible. However, the highly strained system actually disfavors enolization because the geometry required for enol formation is constrained and the resulting enol would introduce additional strain. And for the final step, the key principle for decreasing enol content. The enol content is greatest where the alpha carbon has the most acidic H and the enol form is most stabilized. For these alpha diactones in cyclic systems, the 6-6 fused system, I, provides the best geometry for enol stabilization with an extended conjugated system and least strain in the enol. The 6-5 fused system, 2, is intermediate. The norbornane system, 3, has the most geometric constraint, making enol formation least favorable. Thus, I to 3. Why other options fail? Option B, 2I3, incorrect because the 6-6 system, I, is more favorable for enolization than the 6-5 system, 2, due to better geometric overlap and less strain in the enol form. Option C, 3-I, incorrect, the strained bridged system has the least enol content. Option D, 2-3I, incorrect for the same reasons. Therefore, the correct answer is A. Therefore, the correct answer is option A.